Alright guys, this is your Unit 7 test review. This is a YouTube video used as much as possible to review. It's for your benefit. Watch it over, work out the problems. Alright, and you'll be fine. A function that of the form f of x equals a times b to the power of x is called exponential growth because the function is b is greater than 1. Alright, anytime your b is greater than 1, alright, it's a growth. Anytime your b is between 0 and 1, this is a decay. Alright. And that includes anything where b can be a fraction less than 1, like let's say 0.9, alright, or 0.75, right? That's less than 1. Also, if you had a fraction, something like 3/4. Alright, that's not quite 1, guys. Alright, that's 3/4. Alright, or 7/8. 7/16, something like that. Alright, the numerator is smaller, alright, than the denominator. So that tells you that's less than 1. The next problem here. Alright, next guys, we have a real estate agent estimates that the value of the house could increase by 4% a year. Alright, we need to write an equation that models the growth of a value with a house that has an initial value of $122,000, guys. So, of course, this is our initial value, alright, or this would be A, alright, and then our B is going to be 4%, but we need to convert that to a decimal. Alright, 4% as a decimal is going to be 1.04. But the reason it's going to be 1.04 is because the notes, guys, we learned that what you need to do is you have A times or 122,000 times, since this tells us it's a growth, right here we say it's a growth, you have a growth, which means you add 1 to your decimal. Alright, that's 0.04, so you have 1 plus 0.04, alright, raised to the power of x. Alright, or if you go ahead and solve that, then it's 122,000 times 1.04 raised to the power of x. All right. The next part says the house is worth 122,000 in 2016. Predict the year that the house will be worth at least 150,000. Okay. So what I want to do here is bring up the calculator, guys. So what you do, guys, is you take your calculator, all right, and you want to graph your function, 122,000 times 1.04 to the power of x. All right, of course, hit graph. But you can also second graph, go to your table. And you can actually visually see when this is going to be larger than 150,000. All right, this is your Y column. All right, this is 2016, 2017, 2018, 2019. 2020, 2021, 2022. So somewhere between year 5 and year 6, or 2021, 2022, the house would be more than $150,000. All right, so I go back to our notes. All right, so the houses were, it says predict the year when the house will be worth $150,000. So we're going to say between 5 and 6 years. Wait, no, we're not. We're going to actually say, it says predict the year. All right, so the year, I would say 2022. All right, 2022, because remember, it was over 150. All right, it was 158,000. So, if I'm not mistaken, we'll have to go back to the calculator and look, but you guys have at it, okay? So, 2022. All right, what will be the value of the house in 2026? Again, you can use your calculator, guys. All right, so if we use our calculator, go back to the calculator. It said 2026, that's in 10 years. All right, $180,590. All right, $180,590. All right. So that is that. All right, let's take a look at number two. Number two, a computer value at $6,500 depreciates at a rate of 14.3% per year. I write a function that models this, guys. So first, guys, check this out. We know what A is. That's our initial value, $6,500. All right. Now we take our 14.3% and convert that to a percentage. All right, that's going to be 0.143. Okay. But because it says depreciate, that means a decay. When it is a decay, remember with a decay, it must be less than 1. All right, less than 1. So what we're going to do is we don't add 1 to this, guys, 1.143. We need to subtract that number, 1.143, from 1. All right, so you have 1 minus 0.143 to the power of x, or you can write it as 6,500 times 0.8, excuse me, 857 to the power of x. All right, because 1 minus 0.143 is 0.857. Okay. And then it says find the value of the computer after 3 years, guys, after 3 years. So again, go to your calculators. So you go to the calculator, guys, enter your equation, okay, and then hit graph. All right, then go to your table. Come on, graph. All right, and here's your table, guys. So this was the initial value, 6,500. It says in 3 years, so you go to 3. It's going to be $4,091.20. All right, so let me change programs here again. And we have 4,000. I believe it was up. Hold on, I forgot. $4,091.20. All right, so that's your 2 word problems, growth and decay. All right, make sure you practice that. The things to remember here is if it's a growth, it must be larger than 1. If it's a decay or depreciates or loses value, it needs to be less than 1. All right, so subtract that decimal, whatever your rate is, from 1, guys. Okay. Let's shift gears here and let's look at the compounded formula. All right, and guys, make sure you practice putting these into your calculator. We don't want to run into errors where we're not putting this in right and getting the wrong values. So you need to practice entering these into your calculator. All right, so let's label our parts. Our principal is our initial amount, guys, $73,000 at 7%. This is our rate, which we're going to go ahead and convert our rate. Let's make it 0.07. And then our time, guys, is 3 years. All right, 3 years. That's T. We got to find N. All right, or in this case, we know what N is as well, daily. There's 365 days in a year, guys. We have everything we need to calculate this right here, guys. So the formula is going to be A equals 7,300 or 7,300 times 1 plus 0.07 divided by 365 raised to the 365 times 3. All right. Now, let's actually put this in our calculator. The thing to remember here is you can actually put it in, all right, exactly how you have it written, but you must do one critical step. All right. 7,300 parenthesis 1 plus 0.07 divided by 365 Close it. Now, when you raise this thing, guys, to exponent, put parentheses around 365 times 3. All right. Do that. The parentheses here are so important. These are important. These are important. And you'll get it right. If you don't do that, you're probably going to get your answer wrong. All right. I'm just telling you. Unless you do, well, nope. You're probably going to get it wrong. All right. Now, if you practice another way, cool. Do your thing. Okay. As long as you get the same answer. All right. So we got $9,005.66. We'll go 67. All right. All right. This one here, guys, we got our principal. All right. 55,000. Ooh, 55,000. All right. Times 1 plus rate is 0.16. Divided by, it's just compounded monthly. There's 12 months in a year. 12 months in a year. So that's going to give us 12 times 2. All right. Again, when you put this in your calculator, put parentheses here and here. All right. All right. So I go back to the calculator. 55,000 times 1 plus 0.16 divided by 12 because it's monthly. All right. Some of you guys are great mathematicians, so you know that 12 times 2 is 24. All right. You can do it like that. All right. You can do it like that, and that gives us $75,582.04. $75,582.04. I forgot that fast. 582.04. All right. And then lastly, we have this one here. 28,600 times 1 plus 0.079. All right. Divided by weekly, 52 weeks in a year, right? Raised to the 52 times 2. All right. Or some of y'all could have just put 104 right here. 104. But anyway, when you do that, guys, it's going to give you $33,491.34. All right, 34 cents. All right, guys. So since we're going to change gears here and go into logarithms and exponentials, I'm going to make another video for that. All right. Because this is 13 minutes long now, approaching 14 minutes. So make sure you get, look at the next video. All right. Look at the next video and happy studying.